Welcome to Math Hell. This is the first problem that was requested from the Calculus 2 class, spring of 2018. And I'm going to try to attempt to make this suck less. So this is WebAssign problem number 7 in your homework, which is number 16 in the book. And this is the problem, the definite integral from 0 to radical 2 over 2 of 11x squared over radical 1 minus x squared dx. And this section 7.5 is all about trig substitution, so I went ahead and made this substitution. If you have 1 minus x squared, you should try x equals sine of theta. You can also try x equals cosine of theta, but then you're going to get a lot of negatives running around, so you might prefer to use sine, but it's fine to use cosine as well. I go ahead and I take the derivative. The derivative is cosine theta d theta. Again, if I had set x equal to cosine of theta, I'd end up with a negative sign there. So that's why we choose sine of theta. I went ahead and decided to be nice to you, and rather than waiting till the end, I went ahead and I converted my limit. Radical 2 over 2 converts to pi over 4, because that's when sine is radical 2 over 2. And when x equals 0, we need to find a place where sine of theta equals 0, and that, of course, is at 0. So that was pretty straightforward, hopefully. So I used this u substitution. I called it a u substitution, even though it's actually a trig substitution. So I pulled the 11 from over there, I pulled it outside, and I converted to thetas, and I converted my limits from 0 to pi over 4, and you can see I've got my sines and my sine squareds in there. Next step is 1 minus sine squared of theta is cosine squared, so I made that. And then radical cosine squared gives me cosine, which then cancels, which, depending on your perspective, is either great or horrible, because at this point now, you're going to have to remember how to deal with sine squared of theta. Sine squared of theta actually converts to 1 minus cosine of 2 theta, and I snuck the little 1/2 that we have here, I snuck it in under the 11, because I know you guys like to put all your numbers on the outside. So at this point, I've totally run out of paper. So then I get a new sheet. Ooh, the magic of television. And then I've got the same thing written down, except now I've taken the integral. So here, let me show you both pieces together. Oh, there you go. So then I've got 11 halves, which I've got right there. 1, which when integrated, you take the antiderivative, it's theta. Cosine of 2 theta integrates to sine of 2 theta over 2. The minus stays in place because you're taking the antiderivative, not the derivative. And I'm going to evaluate this between 0 and pi over 4. Okay, so I went ahead and worked out 2 halves. You'll notice that the second half, when we evaluate at 0, is going to be 0 anyway, but I went ahead and wrote it out. You never want to forget about the zeros. Sometimes they won't zero out, and then if you leave it off, get in that habit and you leave it off, then you're going to miss points on that. But I went ahead and plugged in pi over 4. Pi over 4 for theta means here where I had a 2 theta, it becomes pi over 2. The whole thing is over 2 because of the 2 theta. Again, that has to do with the chain rule when I took the antiderivative. And then if I evaluate sine of pi over 2 is 1, so I've got pi over 4 minus 1/2. This entire piece becomes 0. As you can see by the lovely whiteout right there, it becomes 0. This is high tech, guys. And then I'm going to multiply through by pi over, or 11 over 2, 11 pi over 8, minus 11 over 4, which hopefully sucks a little bit less.